Hello everyone. So first of all, I'm going to say thank you to the CubeSat Developers Workshop that have been invited us to present our idea. And due to COVID-19 this year, again, this valuable workshop is going to be virtual. And we hope next year everything back to normal when we can come for this conferences physically. Okay, so let's continue on this proposal. So what we are going to propose is a tropical cyclones monitoring solution using THz technology payload on a CubeSat. So first, what is a terahertz waves? Terahertz is a gap between the microwave and infrared frequency. Terahertz radiation, also known as submillimeter radiation, terahertz wave, tremendously high frequency THF frequency range between 0.1 until 3 terahertz is considered as terahertz waves. Terahertz is absorbed strongly by atmosphere and the signal strength reduced to zero after few meters on the ground. There are several terahertz applications, both terrestrial and spatial items. So here we can see some terahertz applications. We can talk about them briefly. So terahertz pulse imaging, molecular structure, medical imaging, and the mostly important is space application, but important for our presentation, not totally. Okay, so terahertz space application. Here there are three most important terahertz space applications that we will talk about them. Terrestrial application. It includes three parts. First, the use of terahertz wave for observation from geostationary have been one of the subjects for both European and USA space agencies. The missions that millimeter and submillimeter wave can do include total water vapor column, cloud motion vectors, possible ice profile, temperature and humidity profile. Second, remote sensing of the surface of the Earth is possible in foggy and cloudy conditions. The application of terahertz remote sensing includes imaging of sea ice and snow, which the ice cloud is very detective with some millimeter instrument. Third, climatology addresses several very important processes taking place in the atmosphere and detecting what humans' activity affect on it. One of the ideas is to correlate the composition of the atmosphere. Millimeter and submillimeter frequency allow the use of radiometer for determination characteristics of ozone and other greenhouse gases, such as CFCs. Second part, radio astronomy. Observation of both interstellar and extragalactic regions with millimeter and submillimeter waves have been given us a great opportunity to understand our whole universe. This gate technology has a great capability to see star formation through the clouds and dust. Third, planetary and cometary science. It includes two parts. First, another application for millimeter and submillimeter waves is monitoring third body or a small planet such as a moon, asteroid, and comet, etc. The target is to identify atmosphere characteristics and their composition. Second, Martian, Venusian, Jovian atmosphere remote sensing. The proposed idea is about providing valuable data on composition, pressure, temperature, wind velocity of referred planets, which those data unaffected by atmosphere dust and independent sunlight condition. What we are going to do with terahertz? Tropical cyclones monitoring solution using THz technology payload on a CubeSat. So there are three pictures. Okay, so THz technology is a state-of-the-art technology for satellite remote sensing. With its tiny antenna size, can be easily placed on a CubeSat surface. In addition, these tiny wavelengths can penetrate and identify small particles such as water vapor, ice, cloud, dust, etc. Sweeping a target location at different times, this capability gives us a solution to monitor formation process of natural phenomena, such as tropical cyclones. Yearly tropical cyclone force billions of dollars of damage around the globe, takes lives, and bring homelessness muddy water, and even disease. This mission is going to figure out how to predict tropical cyclones by remote sensing and THz technology by a CubeSat system and prevent irrecoverable financial and human losses. Tropical cyclones are one of the biggest threats to life and human sources. They include a number of different hazards that can individually cause significant impact on life and property, such as a storm surge, flooding, extreme winds, tornadoes, and lightning. Combined, these hazards interact with one another and substantially increase the potential for loss of life and material damage. So, forecasting tropical cyclones, a destructive phenomenon by a satellite remote sensing. Look at these pictures. Forecasting tropical cyclones from space is high-level, trustable information which can be worn near habitated area when tropical cyclones are approaching. Figure A shows a tropical cyclone formation. The same location has been monitored at different times. This action provides capability to see the formation of the storm, and if that reaches an area zone, the area can be evacuated. Subsequently, we prevent human and financial losses as much as possible. Figure B shows a comprehensive storm map that it could show us which location the center of the phenomenon is, so subsequently we can alert the near affected area, and in addition, it can tell how much the capacity of the air pressure is. This kind of map really depends on the software we provide for ground station. Here we can see CubeSat system design. Here is the CubeSat first sketch. Totally, this CubeSat contains 3 sections, include payload, platform, solar cells. The payload is proposed as a THz radiometer with center frequency 165 GHz range. We have chosen this center frequency because the water vapor has a strong signal strength at this frequency. This payload assists us to monitor cloud formation and subsequently the tropical cyclones formation. The platform contains subsystems to support the mission. We already have done the analysis such as link budget, mass budget, power budget, etc. The platform contains S-band for payload data transmission, UHF for up and down links, ARM-based microcontroller for OBDH, 3-axis attitude control system with 3 magnet torquers and 45 watt-hour battery capacity. All support the payload. We consider a maximum power tracking mechanism by ordering a connected servo motor with solar cells package. We consider this because the payload requires to point Earth's atmosphere, but the CubeSat power consumption is higher than we can consider a fixed body mounted solar cells to generate power. And eventually follows is CubeSat scenario. As it has been illustrated, we can see that there are defined 3 targets. Those targets have been chosen relative to zones with high risk tropical cyclone capacity. Countries such as China, India, Bangladesh hit by tropical cyclones before. Therefore, we chose target near those countries. Meanwhile, there are zones near Australia and United States which is in the risk of tropical cyclone. On top right hand the figure, we can see how THz radiometer will operate for presenting a tropical formation process. In fact, millimeter waves with its tiny wavelength can penetrate into clouds and detect the cloud will precipitate or as ice participate inside the storm. We suggest for better data accuracy, utilize constellation. It enhances the covered area and better real-time data link. Okay, so it's the end of this presentation, and thank you for listening to me. And if it is any question, don't hesitate to contact me. So thank you.